I saw this car in the trash bin of my neighbor. I just picked it up. Then I thought, why not give a new life to this one? So I opened it up and checked what are the components inside. I see there is one rear motor which is added to the gear. There is another motor at the front which is for basically left-right control, and there is a switch just to turn on and off, and there is a small circuit board which used to control this board which is not working anymore. Previously it used 3 AA batteries which is around 4.5 volt. Now it's time to remove all the existing cables from the old small board, and we will be replacing that with our smart Wi-Fi control board. Now all the existing connections are removed, and I am going to replace that with our own custom designed board. And let's discuss what are the things we need before we can discuss about the diagram and the connections. First thing first, we need the main controller. For that I am using ESP8266, and we can control the entire car or the operations from Wi-Fi itself. Then to drive the motor or to control the motor speed, direction and everything, we will need one motor driver. For that I am using MX1508 motor driver which can control 2 DC motors. Then I am using TP4056 USB charging module for 3.7 volt lithium batteries. I also need one DC to DC boost converter in order to boost the 3.7 volt to 5 volt for the ESP8266 input. I need one BMS just to control the batteries charging and discharging. I am using one 0 PCB just to design my board. Along with that I will be using some female headers where we can connect our ESP8266 or motor driver or any other board, and we can swap it anytime. It is not fixed to the board. We will need few LEDs and few resistors, and obviously the DC motors which I have already found in that car. I was missing the most important part, the power. Without power, nothing happens. Here is the battery, the lithium-ion 18650 battery. And here is our diagram. We see all the components which we were talking about. At the left we have ESP8266, the controller board. Here we have the motor driver, and let's think the front motor, and this is the rear motor. Front motor will be controlling left and right, and rear motor forward and backward direction. I am using D5 to D8, that is D5, D6, D7 and D8 to the inputs of this motor driver to control the motor speed and direction. Then right end it is connecting to the motors as you see, and it is powered by this BMS. This BMS module is connected to the 3.7 battery, and again from the BMS power plus and power minus I am taking the power output to the input of DC to DC boost converter, and I will be setting that to 5 volt just to give enough input for the ESP8266. As you see, the Vin is getting the positive output from the DC to DC boost converter, and the ground is connected to the ground. From D1 to D4 all these GPIO pins are connected to different LEDs. Those LEDs I have installed on the car. I have connected everything as per our diagram. Just I need to put in the ESP8266 in the female header socket. Before designing the final diagram, I had tried many things. Few things worked out, few didn't work. I have blown up one circuit without understanding the proper power requirement and other things, but that happens. Before putting everything together, let's have a discussion on the coding part too. I'm including bunch of libraries: ESP8266 Wi-Fi, ESP Async Web Server, ESP Async TCP and LittleFS, and I'll be using those on the Arduino IDE. And if you are wondering how to install those, I'll be giving a link of my previous video where I have worked with an interesting project using LoRa modules. Please check that out. Then I am defining the pins which will be connecting to what, that we have already discussed in the diagram discussion. I am defining what will be my hotspot SSID and password. This will work as an hotspot module rather than connecting to a router. Then we can take it anywhere and we can play around it. Then I am defining my web server at the port 80, which is HTTP, and obviously I will be using the WebSocket technology in order to communicate from our connected device, maybe a phone, tablet or anything like that. I am initiating the Wi-Fi. initializing the file system or little fs, and here is the control. Depending on the message which we receive from our WebSocket, I'll be putting some bunch of flags, and depending on those flags, card will behave accordingly, like forward, backward and many things. So for this INO file or the program file, you'll see a data folder is there. So let's open this data folder. Reveal in File Explorer, and whenever we are loading this INO file, before that we have to load this HTML, JavaScript and CSS file, and we'll check that. And let me open this HTML file. And here is our UI. As you see, the headlamp control is at the top. HB for high beam, off and low beam, we can control that. Then left indicator, parking indicator, right indicator and off. And then we have the car direction control, forward, backward, left and right. Then we have the speed control, higher number, higher the speed. Then stop means it will stop the car. And on mobile devices or smaller screens, it will look something like this. Let me make it small. So it will look something like this. In order to upload that, make sure you load up the code from the proper folder where the data folder is there. If in the same path data folder is not there, I am going to use one tool which is called ESP8266 fs data upload, that is not going to detect. And if you are wondering how to install this one again, the same video link will give you an idea. Let's click on this. And it has successfully uploaded that. As we see, 100% writing is complete and reset is also done. Now I have copied the same file or the program file in the IDE. Now simply I will be using the upload button in the IDE itself. Let's click on upload, sit back and relax. Once it is uploaded, we can put this in our circuit and we'll see the action. Now it is getting loaded after the compilation is complete. Let's wait a little bit. Now the writing is 100% and the reset is also done. Now we can put everything together and let's see how it works. And finally, our car is ready and we can control everything from our mobile device. Now let's have a demo. Here is our car. As soon as we stop, the rear brake LED glows. We can turn on the right indicator, then the left indicator. We can turn on the parking light. We can go forward. We can go backward. Forward, backward, forward, backward. That was really fun. After so many attempts, it is working successfully. While it is dark, we can turn on the headlamp. Low beam, high beam, both options are there. Along with that, I have added a C-type port on the body of the car. We can charge using a C-type port. Everything remains inside the car. Hope you find this video interesting. Thanks for watching. Let's meet in some next project. Thanks again.